In this problem, we are going to rotate a point about the origin, except this time we are not rotating in increments of 90 degrees, nor are we starting on an axis. So our point is just kind of floating here. So we're going to rotate it counterclockwise 280 degrees about the origin. If we think about like 90 degrees, 180, 270, it's going to end up somewhere like in this general vicinity in the first quadrant. But let's envision this circle that we're rotating around about the origin. The center of the circle is at the origin. So what we're doing is, first, we know we got to get to an axis. So first, if we can figure out what this angle is, whatever that angle is, then we know that to get from this point around to this point, that's 180 degrees. And then we know in total we're going to go 280 degrees. So if we know what this angle is plus 180, then we just can figure out whatever is left over and figure out the coordinates of our new point that's over here in the first quadrant somewhere. So the big question is, how are we going to figure out what this angle is right here? Well. Guess what my favorite shape is in the whole entire world? A right triangle. So we're actually going to drop a right triangle right here and find this angle right here using SOHCAHTOA. Let's drop that triangle. I know that if I start from the origin, I'm going to go -3 units to the left and then +5 units. That's 5 units up. So if I'm thinking about a right triangle, the length of this side is going to be 3, the length of this side is going to be 5, and I'm looking for this angle right here. If this is a right triangle and I know 2 of the sides and I'm looking for a missing angle, I'm going to use an inverse trig function. That's what I use to find missing angles. So if this is my angle right here, x, 5 is my opposite side, 3 is my adjacent side, I'm going to use inverse tangent. So tangent inverse, my opposite side is 5, my adjacent side is 3. So I'm going to make sure that my calculator is in degree mode, and I'm going to go type that in to get 59.0362 degrees. And so you might be wondering, Ms. Briscoe, why didn't you just round this? Well, I am going to use the measure of this angle that I just found later on in my problem. So if I round it now, that is going to mess up the rest of my answer. So I have gone 59.0362 degrees to get to the x-axis. Then I'm going to go 180 degrees to get to the opposite side of the x-axis. So 59.0362 plus 180 gives me 239.0362 degrees. So if I'm going a total of 280 degrees around the origin, if I'm rotating a total of 280 degrees, I need to figure out my leftover degrees. So I'm going to go ahead and subtract 239.0362 from 280, and that will give me 40.9637. This angle is 637 degrees. Okay, so that's a little off. It's just a guesstimation. So in order for me to figure out the coordinates of my new point, I'm going to need to know the distance I traveled along the x-axis, and I'm going to need to know the distance I traveled along the y-axis. So I'm going to need to know the sides of this right triangle. Well, I know an angle. I don't know a side, except for the fact that this is a circle. The radius, the length of the radius in a circle is going to be consistent. So this hypotenuse of the blue triangle is going to be the same as the hypotenuse of this pink triangle over here. So I can go ahead and do Pythagorean theorem on this blue triangle in order to get the length of the hypotenuse. So I'm going to call that c. 5 squared plus 3 squared equals the hypotenuse c squared. 5 squared is 25, 3 squared is 9, 25 plus 9 is 34, so c is the square root of 34. So this hypotenuse over here is the square root of 34. So I'm going to find my x-coordinate and my y-coordinate now using SOHCAHTOA. So I have this angle. I know my hypotenuse, so if I'm going to find x, that's going to be adjacent over hypotenuse. That's going to be cosine. I'm going to use cosine. So cosine of our angle is equal to x, the adjacent side, over root 34, the hypotenuse. So I'm just going to multiply by root 34 on both sides to get x is equal to 4.4. And now to get y, I'm just going to repeat this process, except I'm going to use sine of our angle 40.9637 is going to be equal to y, the opposite side, over square root of 34, the hypotenuse. So I'm just going to multiply by root 34 on both sides to get 3.8. And so x is the distance that I'm traveling to the right, so about 4.4. 3.8, y, that's my distance I'm traveling up. So I'm going to end up actually about right here. So that angle looks a little bit more like that. This point where I end up is 4.4 comma 3.8. So the big idea is, first I had to figure out, well, what was this angle? How many degrees did I need to go to get to the x-axis? How many degrees did I need to travel to get to the x-axis? Because I know this is going to be 180, as I'm going halfway around the circle. I'm going from one side to the other. So I just added the angle I found with 180, and then I knew my total was 280, so I just subtracted that total from 280. That's what I did right here, and then that is my leftover angle. That's how many degrees I have to travel above the x-axis in order to get to my point, in order to complete that full 280 degree rotation. So then I needed to use this right triangle in order to find the coordinates of our point. So I needed to know the x side and the y side of that triangle. So in order to do that, I needed to know a side of that triangle. Well, I know my hypotenuse is going to stay consistent, so I went back to my original triangle. I did Pythag in order to get the hypotenuse, so that was then the hypotenuse of the triangle over here. And then once I knew the hypotenuse of the triangle over here, then I could use trig to get the remaining sides. So the final answer, the point, the location of our point after we've rotated it 280 degrees about the origin is 4.4 comma 3.8.